Hello, this is Mrs. Han. I'm going to show you how to do the summer and winter gizmo. And so hopefully you have your lab sheet and you have your gizmo open. Okay, there's a plane flying over. Okay, so these pre-knowledge questions, these are going to be just what do you think before you get started? What do you know so far? It's okay if you're right or wrong because you will learn. All right, then we're going to do the warm-up, and it says the space tab shows two different screenshots of Earth as it orbits the sun. So here we're in space. This is on Earth and this is in space. So this is the space tab. And hopefully you know that the Earth is orbiting the sun. And so this is a shot of what the Earth looks like in December. And this is what it looks like when it's in June. And I don't know if you can hear that plane, but it's sure loud. So the Earth is rotating around the sun, and the Earth is actually revolving or rotating on its axis. So it's right now this part is day and this part is night, but it's constantly turning every 24 hours on its axis. So it's turning and it's revolving around the sun. Those are the two movements of the Earth. But right now we're going to be talking about the movement of the Earth around the sun. Okay, so number one is asking, does the axis go straight up and down or is it tilted? And hopefully you can see that it is not straight up and down. The latitude indicates how far you are from the equator. So they have this little person in red, and this is the equator here, and this is the equator here. And right now, the person in red's latitude is 36 degrees north. So you'll notice as I move this person, the latitude is changing to go higher and higher north until it's going to be 90 degrees north when she's at the North Pole. And then at the equator, she's at 0. And then she can be south, 52 degrees south. So that is what the latitude is how far you are from the equator. And now we're going to go ahead and this person has the same latitude as this person. It's just showing at different times of the year, in December and in June. So now we're going to show the sun's rays. Okay, and what do you notice about the sun's rays as we're moving her toward the North Pole? So if she's like here, okay, what do you notice about the sun's rays? And as we move her farther toward the North Pole, does it seem like the sun's rays are more direct or less direct as she's moving up to the North Pole? Okay, so that's what this question is asking. And then number 3 says half of the Earth north of the equator is called the northern hemisphere. So this top half is called the northern hemisphere, and this bottom half is called the southern hemisphere. And 3A is asking which hemisphere receives more direct sunlight on June 21st. So in June 21st, is it the northern hemisphere or the southern hemisphere that's getting more direct sunlight? And in December, which hemisphere is getting more direct sunlight? Is it the southern hemisphere or the northern hemisphere? Let's go to activity A. So in activity A, it says we want to still be on the space tab. We want to drag the person to 40 degrees north. So right now this person is at 26. I'm going to move her a little higher so that she's at 40. Okay. And then show the sun's rays, which we have. Okay. So hopefully you know about seasons. We've got 4 seasons. And the summer solstice is considered the first day of summer. The winter solstice is considered the first day of winter. Summer solstice is June 21st, and winter solstice is December 21st. Question number 1 is asking, what do you think? Why do you think it's colder in winter than summer? Why do you think us here in the northern hemisphere, why do you think it's why do you think it's colder in December, here we are, than in June? So this is us in December and this is us in June. What do you notice about the sun's rays? Number 2, now we're going to collect some data to see what the actual answer is. We're going to select the Earth tab. Okay, and in the Earth tab, we're going to be collecting this data. How many sun's rays are hitting the solar panel? So we have a little, I don't know if you can tell, but this is supposed to be a solar panel. And we're supposed to count how many sun's rays are hitting it in June and how many are hitting it in December. And then what is the temperature, what is the daylight hours, and what is the sun's rays angles? Okay, so first let's go ahead and put how many rays are hitting the panel. Now, you just need to count how many of these arrows, which are the rays, are hitting. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 rays are hitting the panel in June. And then you will count how many rays are hitting the panel in December. Let's see what the temperature in June is. The temperature is 34 degrees Celsius or 93 degrees Fahrenheit. You can shoot, oh, it says to do Celsius. All right, so we'll put 34 degrees Celsius. How many daylight hours are in June? So you know in June, in the summertime in the United States, the sun is out longer. It doesn't go down as early. So there are 14.9 daylight hours per day in June. Okay, so I would write 14.9, and then I need to show the sun's ray angle. So the way we do that is I'm going to use this protractor, and I'm going to put the T along one of the arrows. So I'm picking this arrow to kind of put right at the T, right at the center. And then this is going to tell me if the ray went straight up and down, then this would be a 90-degree ray. But the ray is actually kind of going this way. It's a little bit angled, and this looks like it's not 60, and this is 70, and this is 80, and this is 90. So it's maybe 74 or 73 degrees. So I would put 73 degrees. I don't know how to make that little degree sign, but it's a tiny circle. Oh, yeah, okay. Then you're going to do the same with December. You're going to count how many rays on the panel. What is the temperature in December? Okay, right here. Quite cold. How many daylight hours are in December? Okay, right here. Ooh, it gets dark early and it doesn't get light until later. Like you wake up and it's still a little bit dark. And then what are the sun's rays angles? So I would have to move this protractor over, and I would put the T at the bottom of one of the rays. Let me do one. Okay, I'll do this one. And then I would follow this ray to right here and see if I can figure out what angle that is. So this is 30, which means this is 20, which means this is 10, and 0. So what would be this number for the angle of this ray? Okay, but you can tell right off the bat that the angle of the ray is much lower. It's not as straight up and down, which would be 90. It's much more angled. Okay. So after you've got your table filled out, you're going to answer these questions. On which day are there more hours of daylight? Which day does more sunlight hit the solar panel? And how does the angle relate to the temperature? Okay. So does the angle seem to affect the temperature? Let me see. Yeah. If the angle is steeper, is it going to be a higher temperature or a lower temperature? Okay, so now number 4, you can give 2 conclusions why it's colder in winter than summer. You can talk about the daylight hours. You can talk about the angle of the sun, whether it's lower or higher. You can talk about yeah, I think those are good reasons. I would focus on angle of the sun and daylight hours. All right. So B, this is now, so this whole time we've been on the northern hemisphere up here, okay, where North America is. And now we're going to move this person down to 40 degrees south, which is New Zealand. And New Zealand is 40 degrees south. And this is kind of cool because, you know, we always think of winter as December, summer as June, but some parts of the world don't have the same seasons during that time. So here we are in December in the southern hemisphere, and look at what the sun's rays look like in December in New Zealand. And look at what they look like in New Zealand in June. Okay? Whoa, not much sunlight right there. So you're going to pretty much answer the same questions. Look at the how the sun's rays are hitting, and go ahead and give your hypothesis. And then you're going to go to the Earth tab, and you're going to do the same thing. So this is what it looks like in December in New Zealand. Okay, and you can see the sun's rays are much steeper, and the temperature is much higher, and there's more rays hitting the solar panel. And here in June, it's like wintertime, which is kind of weird for us. Okay, so you're going to answer those questions. You're going to say, what is the first day of winter in the southern hemisphere? Okay, so this is going to be, remember the dates are June 21st and December 21st. So for the southern hemisphere, what is their first day of winter and what is their first day of summer? Okay, and then I think you can answer the rest. This is an extra credit section if you're curious what happens when you're on the North Pole or the South Pole, where things are very extreme. So that's kind of cool to look at too. But I will leave that for you to do. All right, if you have any other questions, feel free to stop by my Zoom or email me.